This video investigates Anomaly 72, the architecture and erasure of Claude Fable 5. We will explore the limits of frontier safeguards and the brief 72-hour lifespan of this state-of-the-art model. The history of the Mythos-class models was short, spanning less than 3 months from public leak to state-mandated blackout. Fable 5 survived just 3 days in general availability. As noted by Robert Nogaki, a state unilaterally switched off a frontier AI model by letter, using export control as the instrument. This set a precedent for process-free discretion. Fable 5 was more than a smarter chatbot. It was a Mythos-class 1 million token reasoning engine. A key feature was its adaptive always-on thinking mode, which dictated reasoning depth based on prompt complexity. Fable 5 delivered a significant, quote, capability premium. On unguarded benchmarks, it doubled performance on the hardest agentic coding evaluations, showing substantial gains across multiple metrics compared to Opus 4.8. The raw cost of Fable 5 was high, $10 per $50 per million tokens. Making it economically viable required architecture optimizations, like the batch API and prompt caching, to dramatically collapse input costs. Adaptive thinking was mandatory. Fable 5 stretched its latency and compute to match the problem. This was unpredictable for simple chat, but engineered for asynchronous, long-horizon agents and strictly enforced by the API. Fable 5 and Mythos 5 were the twins, the exact same underlying neural network. Fable 5 had a strict membrane for the public, rerouting dangerous domains. Mythos 5, for cleared cyber defenders, had zero restrictions and full access. The router paradigm meant Fable 5 was a reasoning engine designed to dynamically downgrade itself. For guarded domains, safety classifiers intercepted restricted prompts, routing them to the previous generation model, Opus 4.8. This "agrab control" involved wrapping the powerful Mythos weights in a classifier membrane. High-risk queries, such as a zero-day exploit request, were never allowed to touch the frontier core, instead falling back to Claude Opus 4.8. The API payload routing used the refusal paradigm. A blocked request was not an error, but a routing signal. When the safety classifier fired, the system returned an HTTP 200 with a refusal reason, enabling server or client-side fallbacks. The safeguards were necessary due to the weaponization risk. The underlying engine was a proven, automated vulnerability discovery platform. It found vulnerabilities in major operating systems and web browsers, and was used to generate a novel memory corruption exploit. The critical event was the glasswing fracture. The membrane around Fable 5 held, but a jailbreak was discovered within the unprotected Mythos model. Since Fable and Mythos shared weights, this compromised the trusted access model. The U.S. Commerce Department mandated an immediate block on foreign nationals. However, identity verification at the API key level was impossible to engineer in 72 hours. The resulting action was a complete global blackout, the kill switch. The legacy of Anomaly 72 shows that we can build self-routing safeguards for dangerous models. But its 72-hour lifespan proved that technical safeguards mean little when state policy can unilaterally sever access. The frontier of AI is now bound by process-free discretion.